Physical evolution and its effects, Part 2. The emergence of the science of thermodynamics. In order to research this, it was necessary to know the foundations on which the knowledge sciences were built, foremost of which are the sciences of physics and what deviates from them. And which among the most important results are the first and second laws of thermodynamics, which provided the opportunity for hard-working and inventors to develop power generation machines. Starting from the 17th century onwards, the atmosphere became ready to answer the questions raised at the time. What are the building materials of the world around us? Which consists? What are the elements that make up those materials that make up that world around us and of which we are a part? What are the rules of the common relationship between them? Why do some of them turn into another, as happens when water evaporates or when burning? Why do we feel the smell of flowers at a certain distance, and what is the reason behind that? What is the power? What is the relationship between the different powers and what is their nature? What is the relationship between motion and heat? What is latent heat? What are the laws of pressure and its nature? How much fuel do we consume? And how much energy do we produce? What is the thermal efficiency? And what is its mechanical equivalent? What are the secrets of this universe and what we see in it of criminals and stars, and the relationship between them and each other, and the laws that govern them? To the last of these questions raised. First, what are the building materials for the world around us? In fact, scientists needed a step or a second leap similar to the first step of humanity when the ancient Egyptians discovered the elements of the language of hadith and the rules of writing and interactions that produce all the combinations of words, sentences, and meanings. They needed to know the elements of the language that nature speaks, interacts with. In order to it produces everything we see and witness and what we have not yet witnessed in the depths of the universe.
Physics was the greatest means of this leap to answer the questions raised by the development of its research. After a long and painstaking research journey, scientists were able to discover the elements, letters, of the language that the universe speaks, interacts with, and know the laws of nature that govern these cosmic interactions, conversations. And just as the ancient Egyptians determined 7,000 years ago the letters of the language with a certain number of letters, elements, and determined the organizing rules governing them, physicists determined the number of elements of the universe that make up the letters of its language by about 118 elements that form the basis for everything we see around us. From sand, rocks, or water, airs, smells, colors, etc. Then they began to study them and deduce the laws that govern them. In order to realize the importance of what physics has provided us in the field of matter and energy research, it is necessary to trace the sources and steps of the development of the stages of this science. This may not be the shortest and easiest way, but it is definitely the most enjoyable.
The historical sequence of the march of knowledge of world-building materials.
The beginning was with the Greek philosopher Democritus, who was the first to realize, after deep contemplation, that bodies appear to be solid, while in reality they consist of very minute bodies. The shape of these particles differs in different bodies, but they are so subtle that a person cannot see them with the naked eye. For this reason, all objects appear before us as if they were solid. Democritus called these indivisible, minute particles that make up matter and the rest of the other bodies the name atoms, which means indivisible in Greek.
English physicist Dalton, 1766 to 1844.
He is the first to introduce atoms into the field of science and make it a vital topic for research. Dalton proved the existence of chemical laws that can only be explained by resorting to perceptions of atoms. Atoms entered the field of science steadily immediately after Dalton.
One of the manifestations of proving that matter is composed of atoms and molecules is the phenomenon of expansion and diffusion. So how can the same amount of matter, if it is not made of atoms, occupy different sizes? Evidence that the substance consists of very small atoms and exists in very large numbers can be noticed in the issue of the dispersion of the substance. For example, it can be dyed, blue Nile, which is in the form of small needle crystals that can spread and disperse and stain more than a ton of water. Also, atoms of gas molecules can spread and make you feel their scents from long distances. At the present time, we have knowledge of the names and numbers of all the elements in nature. And we know that they are 118 elements that make up our planet that we walk on. The air we breathe and the stars that you contemplate. Even we humans have been made, our bodies are made of different chemical elements. But 200 years ago, that is, before Dalton, these elements were in the stage of discovery and research. At the beginning of the 9th century, only 55 elements had been discovered. From liquid mercury to sparkling magnesium and volatile iodine. Scientists had no idea how many elements they would find, or that there were an infinite number.
The most important question was, how do these elements fit together, and is this random, or is it a world of elements born of order and logic? This was a baffling challenge, and the first glimpse of a solution came from an unlikely source. The answer to this question will be in the next video or part 3.
Do not forget to subscribe to the channel and support us to continue and provide everything that is useful to you.
Thanks for watching.